Welcome to the episode 4 of the Getting to Know GIS series. This episode, we are looking at the meaning of GIS. This episode is premised on the fact that many people use GIS interchangeably with the software. So they mention GIS and then they are actually referring to a software. But then GIS is not necessarily a software, but goes beyond just a software. That is the premise on which this episode was prepared. Now, two streams of meanings can be put up as to explain what GIS means. The first one is GIS, meaning Graphic Information Science, and then the second one is GIS, meaning Geographic Information System. Now, GIS as a science. So as a science, it deals with principally three basic things: epistemological view, ontological view, and then the various approaches. If we talk about the epistemological view, GIS as a science deals with how reality is known or learned. So if you are thinking about same example as cited in other episode, erosion, how erosion is studied and learned, how erosion is understood, deals with the epistemological view of GIS. That's looking at GIS as a science, the theories behind it, the scientific approaches behind it, how the understanding of erosion as a phenomenon can be brought about, is the epistemological view of GIS. That's viewing GIS as a science. Now, if you talk about the ontological perspective of GIS as a science, we are talking about what is reality. So now there are various ideas about the same example being erosion, which people have opined to it. But then, to you, what is erosion? What is the scientific basis of erosion? What do you understand if somebody mentions erosion? So that is ontological view of GIS. So based on the ideas, based on the theories, based on the scientific perspective, what's considered as erosion to me will be different from what is considered as erosion to you. The levels, the dynamics, the differences all comes under the ontological perspective of GIS. We are applying GIS erosion. This ontology also comes to play. Now, if you realize the ontology, what the reality is, how it's being studied or learned, or how it's being known, comes out with the epistemological view of GIS. That's, you are seeing GIS as a science. Now, there are two levels of approaches in GIS: the developer approach, then the application approach. So now to the developers. GIS as a science deals with the theories behind how societies can be understood, how issues about those societies can be solved. So it brings about the necessity to develop applications, to develop softwares, to develop means by which these solutions can be brought about. So those are the perspective or the theoretical understanding of GIS to the developer. Now, if you come to the person applying the GIS or applying the output from the developers, the person doing the application also is thinking about how what has been developed is able to bring about the solution that the person wants. So depending on the nature of the solutions, the data available, the issues that the person wants to understand, the person might stick to this application or the other application, depending on the pros and cons of that application. So if you are talking about GIS, then we have GIS as a science that deals with ideas, philosophies behind the use of GIS, the scientific basis behind the use of GIS. It deals with the ontology, where what the reality is, epistemological view, how this reality is known, and then the two approaches: if you are using GIS as a developer or using GIS as somebody applying what has been developed over the years. Another level of understanding GIS is seeing GIS as a system. So I think basically this is what many people ascribe to, seeing GIS as a system. Now, GIS as a system, it has 5 components. data, software, hardware, processes, and then the human aspect of GIS, which will be explained in subsequent. Some meanings have been put across as definitions and meanings of GIS. Some that can still be said to be relevant are these. They explain GIS to be specific information system that is applied to geographic data. There is no necessarily GIS when there is no geographic data. Data that have been collected from a particular area on Earth or even in other areas, or data that can be pinned to a particular area in your area of interest that you are studying. So the same example being, let's say, ocean, or here, let me even cite malaria. So malaria is sort of an abstract phenomenon, but then if you want to apply GIS to it, then you have to make it geographic. Where exactly in the area are the malaria reported cases coming from? So you are pinning the phenomenon malaria to a particular geographical space so you can understand it the more. The second one is mainly referred to as a system of hardware, software, personnel, and procedures. So apart from the geographic data, which is very important in GIS, very important in GIS, GIS is also a system, a collective of hardware, software, personnel, and then procedure. The basic fundamental application of GIS is designed to support the capture, how information is captured, how information is managed, how information will be manipulated, looking at the plethora or the abundance of information that we have. The manipulation of information is very critical in the aspect of GIS. How this information can be analyzed. If you want to model the future or look at the trends in data, how the modeling will be done, and even how these abstract phenomenon, which have been given spatial perspective or connotations, can be displayed in reference to a particular spatial data so that complex planning and management problems can be solved. So these are the various aspects that comes together to form a GIS, or to form GIS as a system, which the intent is to have a particular setup that is able to solve societal problems and challenges we have in the society. But as I indicated, the primary basic fundamental issues with GIS is GIS data. So we can have spatial data and then the attribute data. Softwares have catalog or database aspect of it that is made them able to analyze such attribute data. But then spatial data is something that we can't do without GIS. And then as a component, we had a hardware. So the hardware comprises of the input devices that is used to put data into a GIS system, the storage devices that stores the information that are put in there, and then how the information is visualized with the output devices. If you can see this image, it has several means by which the hardware component of GIS can be perceived and seen. The disk, the printer, the plotters, the scanners, the screens that you see, the various output that you have realized, or the process that gone through, the results that has churned out, how you're supposed to visualize it, are all part of the hardware component of GIS. If you're talking about the software component, then we're also looking at the tools that makes the input and manipulation of GIS information possible. So it has the database management system, tools that support geographic query, visualization, analysis of the information put there, and then the geographical user interface that makes the tools that you want to use accessible are all part of the software component of GIS. So these are several examples. There are several softwares that are GIS enabled for you to be able to understand or use, or be able to have access to geographical data, manipulate it, visualize it, and use it to solve complex societal challenges. The others map before, several of them which keeps on being changed, keeps on being updated, keeps on being developed over the years. Now, the human aspect of GIS is also very, very important. There are several instances where there is a hardware, there is a software, there is some bit of geographic data, but then the human aspect who is going to use that data, analyze that data, is falling short. So, as much as you are seeking for, you are looking out for softwares and data and all that, you should also be cognizant of the fact that human aspect in GIS is also very important. So you can be a GIS manager, the person can be a GIS specialist, an engineer, information system analyst, and all those professions that we have in the GIS perspective, they form the human aspect of the GIS. And then we have procedures. Now, looking at the 4 components, you have to put all these things together. Now, the procedures are well designed. You want to analyze or understand how malaria is spreading, you have to base your argument on what is happening in the space. So you have to put in spatial reasoning, you have to put in representation of space, and then the human understanding of space. How is this phenomenon happening? How is this phenomenon going on in this area? All these things comes together as the processes and methods, procedures by which such information can be obtained. Now, taking spatial data, what are the processes that you are using, the methods by which you are taking it? Are you using GPS? Are you using some better accuracy level devices or equipment? How are you taking all these data and how are you going to process it, analyze them using the various tools at your disposal? All comes together to form the procedures or the methods as a component of GIS. It can be business rules, it can be set up already, it can be a workflow that is there for you to do by, or it can be something that is unique to organization. So for this particular organization, this is how analysis should be done per this particular availability of data, or this is how understanding to this phenomenon should be attained. All these are processes that are possibly laid down at a particular organization and is unique to those organizations. But in all, processes are dynamic. It deals with frameworks by which analysis of GIS can be attained. So running up, I'm saying that we have 5 components of GIS. We have the data, we have the software, we have the hardware, we have the humanware, the liveware, and then we have the procedures. All these components makes up GIS. Thank you very much for joining this episode. You can send us emails, you can tweet at us, you can send up WhatsApp messages. Your concerns, your questions are all welcome. Let's go to the next episode. Thank you.